Most of what we'll care about in code is the behavior. And so to get to that behavior, we need to understand methods. Methods is where all the behavior in a Java program is going to live. But remember, a behavior lives inside of an object. So the behavior defines, a method defines what an object does. They do more than just group data. It's not a record structure from some other languages that just stores data. They're records combined with data. And so the objects are going to be co-located with the data. So when I talk about a product and I ask how much is the product, well, I have to ask that object. I can't just go get it myself. I can't just rip the price off of a project. In that case, I actually am interacting with it. I have to go to the project and grab it and figure that out. So here we can see our order has some behaviors. We can add a line item. We can get a line item for a product. We can calculate the total. We can print a receipt. All these different things I can do with the line item. But it's based off the data from that line order. What was the date the order was created? What's the total weight of everything inside of there? What's the total price of everything inside of there? What are the line items inside of there? All of these are things we could be tracking as part of that order. So in Java, we basically are using methods equivalent to some procedure or function or other subprogram name. It has a name, it has a parameter list, and it has a return type. And all of this in Java is put into one quick and easy line. So what we can see from our Java application is the name of some of these methods: add, get, calc total, print receipt. Those are the ones across here. So every method must have its name. Every method has a return type. Void says I'm not returning anything. I'm just doing some work. Here you can see that the return type can be a class, a line item. So I'm going to return a line item. Or a simple attribute or data item, basically a primitive, such as double that's coming up inside of here. And then it also has a parameter list. So it can be empty, open parenthesis, close parenthesis, right there. Nothing gets passed in. Or I can pass in one item or 2 items or 10 items. We'll see as we go. But it has to have all 3 of these elements. Now the public is optional, because the public is what makes it visible to everybody. It could be private, it could be left off and be default, but then the method's not available as much to everybody else. For the most part, methods will also have an implementation, open curly bracket, close curly bracket. We'll see that as we go. We don't care about that for the moment. We're just talking about declaring them. So the implementation side is where you've spent most of your time so far. You've been given a main method, and you've been writing stuff inside of there, whether it's decisions through if statements or loops or whatever you've been putting inside of there. All that stuff is what gets shoved into the method. And it basically just has this block, the open curly brackets and close curly brackets. As we saw before in the attribute example, that's what contains all the work for that method. Once you hit the end curly bracket, it's over. That method's work is finished. And you can have a bunch of methods, as you see here, inside of an object. The body must come immediately after the declaration. So it's not like like some languages, you have a declaration in one spot and a body in a different spot. Sometimes they're in different files. It's all put together in one file inside of a Java program. But you could have an empty body. You could have a method that doesn't do anything. Maybe you just haven't implemented it yet. Maybe there's a reason you want no behavior because of some special case. But there has to be at least an open curly bracket and a closed curly bracket, typically with ifs and for loops and while loops and switches and all that stuff that we've talked about before. So parameters are an important part of declaring methods because they are what takes a canned behavior and turns it into a customized behavior. If you went up to your phone and your phone only played one song on its music player, then you'd really get sick of that phone and that song pretty quick. That's when we first had MP3 devices. That's what they were. They played one song because that's all the memory they could fit on there, and there was no real easy way to, they didn't have USB micro and all these different ways of being able to put stuff on and off of little devices like that. And so what we want to do is we want to parameterize. Like you go to Jukebox, you say play this song, and we've had the notion of parameterization for a long time. Any vending machine you go through, you type in. You put your money, you type in what you want, you get the thing out of it. And so we can have parameters for a variety of reasons in Java. For instance, add is giving data to either store or update something inside of the class. I can modify, in this case, add a line item to an object to an order, excuse me, that's going to get something back. I could use the parameter as a way of just giving guidance, giving search criteria, giving options of how a functionality will happen. So in this case, for the product, I'm going to go search all of my line items and figure out which line item has the cheese as part of it. And it's going to return that line item so I can know how much cheese I've purchased. I've purchased 3 blocks of cheese or 10 blocks of cheese, whatever I'm chosen to do inside of there. So it can guide it inside of there. Or I can provide no parameters. Just deal with whatever data that's happening. Now, whatever data that's happening doesn't mean it's the same behavior for every object. The total of this order is based off of the other behaviors I've done before. What other line items have I added in? So it's modified mostly by the attributes that are stored for that object. If you've put stuff in your shopping cart and call calc total, maybe you get $50. I put stuff in my shopping cart, maybe I have $500 because I've added more stuff. Likewise, printing the receipt is going to pull from all these attributes that I've stored within my class. So just because I don't have parameters doesn't mean I don't have customized behavior. It's just that I'm not customizing the behavior through my calls by either updating or providing details about what I'm looking for. So every Java method must have a parameter list. It could be an empty list. That's, again, open parenthesis, close parenthesis. But I still have to do it. Every time I declare a method, every time I call a method. That's how I identify it as being a method, is by having my little parameter list after my dot and whatnot that's being called. I could have a single parameter. So one data type, one name. And the name of the parameter is completely up to you. Whatever makes sense for how you're going to use that variable, how you're going to use that parameter inside of your program is what you're going to name it. It doesn't even matter to the caller. The caller doesn't see the name outside of reading the source code. You could have multiple parameters in the list, each of them separated by a comma. Here's an example of 2. I can have 3 or 4 or 5 or 25 or 50. However much typing you want to do, I can have parameters separated by a comma. Each parameter has to have a type and a name. So I have a count, I have text, but they each have the count is an integer, the text is a string, and so we can have any number of them coming in that manner. Now, when I have multiple parameter lists, it's important to understand that type and order matter. So when I have int followed by text, when I call this method, I've got to give you a number followed by a string. And I can't switch those around. That's not what's being expected for it. And the order matters because there's no way of me being able to assign them by name. Some programming language could say the count is 7 and the weight is 5 or something like that if weight was a parameter. So I can assign specific things. It doesn't matter about the order. Java order is vitally important. So I must use the parameter list exactly, and I must define it exactly how I want to. And so in order for the parameters to be called, I have to really know what that specification is. We've seen a lot of methods being called. This is mostly looking at how we specify them. So what I want you to know is when you think about specifying the method, you probably want to think about how people are likely going to call it. So I want to put my parameter list in a way that makes the most sense. So if I have something that does Pythagorean theorem, I normally think of a squared plus b squared plus c squared. So I don't want to do bca when I think abc. That's just an example of logically ordering the way we create them, because you're going to help the user. Because particularly if the same type is used for each parameter, if I put them out of order, the only way I know is through testing. I can just see that the example's wrong, or the answer's wrong when I pass it in, but compilation-wise, the only way I can do it is by type and order. All right, so that's a little bit about methods. We have a little bit more we want to talk about methods. We'll talk about the return type of methods next.